may I invite the first group to join the stage. We searched an interesting topic about application of the Deepsurv model for predicting survival in very low birth weight neonates in the ICU, presented by Iskander Isgandarov from Asfendiyarov, Kazakh, National Medical University.
Good afternoon, distinguished colleagues, researchers, and guests. I'm Iskander Isgandarov from Kazakh National Medical University. Now I'll present my work. So if we talk about the relevance, despite the advances in neonatal care, developing countries still face with the high mortality risk that's shown on those dynamic graphs. So, on the other hand, infants weighing less than 1,500 grams still faced with a high mortality risk, and general reducement of the mortality is not applicable for those patients that show in those two epidemiological studies. And in this case, this is thus a critical need to the proper assessment of the risk for those vulnerable group of the patients. This is a critical need. And on the other hand, machine and deep learning approaches are a very useful tool for the capturing nonlinear interaction because the traditional scoring system rely on the limited set of the predictors. So, if we talk about the goals and objectives, our primary goal is to identify the best survival modeling approach to predict mortality in very low birth weight infants. Our objectives is first to compare the effectiveness of the deep learning model with the different traditional machine learning and classic survival models. Our objectives first is to compare the effectiveness of the deep learning model with the different machine learning and the classic survival models for predicting neonatal mortality in very low birth weight infants. Second is develop an online web application for predicting mortality in very low birth weight infants based on best survival model. Next, our methods. Our study follows retrospective cohort study design, which included data from 1,166 patients from the 4 intensive care units across the 2 cities in Kazakhstan. Study is approved by the local ethical committee of the Kazakh National Medical University. After data cleaning, our final analysis included 958 patients. Then we evaluated the Baruta random survival forest algorithm to select best variables for the analysis. Then we divided our set into the train and the test set. Then we evaluated 3 survival models. First, the Cox proportional hazard model, which relied on the limited set of the predictors, linear interaction. It should assess the proportional hazards. Next, it's a random survival force model. Random survival force, it's an assemble tree-based model which could capture nonlinear interactions. And last, it's a Deepsurv neural network which extend the Cox architecture but capture more complex data sets and could work with the large data sets. Our total workflow encompassed the data cleaning, feature selection, model training, model validation, and ultimately deployment of web-based risk calculator. So let's start with the results. Our Baruta algorithm selected 11 key features, those demonstrated from the right side of the slide. So during the model assessment, with the ROC curve, area under curve, Breyer score, and integrated Breyer score, Deepsurv is consistently outperformed all models, showing the best performance across the whole study period. It yielded highest net benefit across the 7 and 28-day periods, which are essential for the neonatologists. And it yielded lowest prediction error across the whole follow-up period. Metrics shown by the lines on those graphs. So calibration curve analysis is also applied, and Deepsurv also showed the best performance. Other models show modest deviations. By the line, perfect line should lie on the diagonal. We could observe diagonal. risk stratification. Risk stratification is a very important task for the clinicians because by the risk stratification we could improve the state of the patients and provide them individual care. And all models show the good separation between the strata. That means that model perfectly divide patients into the high and low risk groups. To show like clinical benefit of our model, we applied the decision curve analysis. Deepsurv there showed the best net benefit across the wide range of the risk thresholds. That means that usage of the Deepsurv model is, could improve the state of the patients compared with the other strategies. Deepsurv with the purple line we could observe. It showed the best performance. Finally, to address the concerns about the model transparency, we applied the SHAP algorithm, which shows the individual predictions of the all variables and could give clinicians like trust for our models. Yes. And during our results, we developed a free web-based multilingual calculator which integrates the Deepsurv model. It's called the neonates. Clinicians could enter data of the patients and receive the results, risks, thresholds, risk probabilities of the mortality for those patients, and it worked dynamically. If we talk about the practical application of our tool, it's officially registered at the National Institute of the Intellectual Property. Our tool is also integrated into the 2 hospitals in the Kazakhstan, in Almaty and Taraz city, and it's actively used by the clinicians there. So, in conclusion, the Deepsurv architecture showed the best performance compared to the classical regression and machine learning models. Our survival calculator with 11 parameters was developed to improve the patient states of the neonates. So by our findings, we wrote the article which is reviewing at the Nature Scientific Reports Q1 journal. It's available by the DISDOI index. And our calculator is also available by the simple QR code. It's free and it's used not only in Kazakhstan, but it's used worldwide across the different countries. It's also integrated there. And thank you for your attention. I welcome for your questions.
Such a captivating topic. Judges, do you have any comments or any questions?
Okay, your work is excellent. You not to only report the result, but also you develop the preterm newborn survival calculator net banking use in the practice. I have one question. Do you collect the data retrospective from the medical record or the obtained informed consent from the mother?
We collected data retrospective from the clinical basis. It's downloaded but if we talk about the retrospective, all predictions is manually checked by the cross-validation, case-by-case validation it's called, by the clinicians. Clinicians approve this calculator. In this case, this dose calculator is officially integrated because it's manually checked by the predictions. Like retrospective collection, but prospective validation of our predictions. Yes.
Thank you.
The tool is very interesting. I just wonder, do you think for using this tool, how can this changing the current practice?
Firstly, we should talk about the financial burden, financial and the time burden for the clinicians, because it's a very important problem, but less of people talk about these problems. And by this case, we could check our risk strategies, to immediately divide our patients for the risk groups and give them weights for the intensive care units or perinatal care centers. We could provide them individualized care because we could observe the risks. And for example, in Kazakh practice, clinicians apply like several scores and including our calculator. They develop strategies, for example, for treating of the patients, for the dosage of the drugs. And this tool is like a little bit advisor for assess risk. How patient state is like several or not several, because it's for dynamically. For example, APGAR score, APGAR 5, APGAR 1 minute score. They're assessed only like cross-sectional in the one like line of the period, like 1 minute or 5 minutes. And in this case, we like high APGAR scores, we put them into the intensive care units. Low APGAR scores, we put those patients into the perinatal care. And by this calculator, we could change parameter. For example, those patients don't have a intraventricular hemorrhage. But if this state developed after, we could like change parameters and receive new predictions. And in this case, we could like dynamically work with the patient upon to 100 days, we could see. Risk curve is upon the 100 day. We could observe different risks for different time periods and work with like dynamically with the patient.
So thanks for the innovation. Okay, it's very good. My maybe not really question, but maybe a comment, because your outcome is just looking at survival only, but actually, I'm just thinking that maybe you could integrate not just survive or not survive, but in terms of healthy life after survival. That could be something else that, you know, like survive but not in good condition. And
Thank you for
survive
your comment.
and with good condition that may support your model and this app more practically. Okay.
Thank you for your comment. We currently work with the other states, and at the December and January, I guess we'll add new features, because we currently work with the different states, like predictions of diseases, predictions of the healthy life. We work currently with it. Thank you for your comment.